And now, dear grade 9 students, we are going to learn how to write the equation of a straight line if it passes through two given points. Note that the slope of any line AB, if the line is named AB, then its slope is given by A of AB equals YA minus YB over XA minus XB. So this is the property or the rule related to a slope. We use it whenever we have two given points. For example, we have given A, we have given B, and we are going to find the equation of a line AB. First of all, we have to find the slope of the line AB. We have to maintain the slope. If the line is named EF, for example, then to find the slope of EF, we apply this rule by writing YE minus YF over XE minus XF, or we can write it YF minus YE over XF minus XE. Never mind what point is first, but what minds is that Y, the ordinates should be in the numerator and the abscissa should be in the denominator. So you have to keep this rule in mind. Now let's continue to know how to determine the equation of a straight line knowing 2 points on it, and this is an example to make things clear. Given the points A of coordinates -1, 2 and B of coordinates 1 and -1, we have to write the equation of the line AB. So we don't have a slope, we don't have a y-intercept, we don't have a line parallel to it, we don't have a line perpendicular to it, so never of the previous methods will work here. So I have to maintain the slope using this rule. That's the first step. So again, the first step is to maintain the slope using the rule of the slope. It is YA minus YB over XA minus XB, and I start evaluation. YA is 2, YB is -1, -1 will give +1. XA is -1 and XB is 1, then I will get -1, -1. Then it is 3 over -2, which is indeed -3 over 2. And by this, I maintained the slope. I still have to find B as usual. The line AB is then written as y equals -3 over 2x plus B. So who remembers what should we do to find B? I used the help of any of these points that are on the line. So I just evaluate the coordinates of any of these 2 points, A or B, in place of y and x in order to find B. So I choose A belongs to AB, then YA equals -3 over 2XA plus B. All what I have to do is to evaluate. In place of YA I put 2, in place of XA we put -1, we make some calculations to get B equals half. Then the equation of line AB is y equals -3 over 2x plus half. And here is the decreasing line AB because its slope is negative. It passes through the point A -1, 2 as you see here, and it passes through the point B 1 and -1 as you see here. And finally, here are more examples concerning special cases. Example 1. Given 2 points A -1, 2 and B 1, 2. We have to write the equation of AB. If you are going to apply the rule of the slope, we will get 0 because YA minus YB will give 0. Now let's notice something special here. We notice that YA and YB are both equal to 2. Then definitely AB is parallel to the x-axis. Notice the figure. A is -1, 2 and B is 1, 2. So A is here. Here is point A. And Here is point B. Since A and B have the same ordinate, then they are on the same level. Then they are on a line AB that is parallel to the x-axis. And let's go back to the special lines. What is the form of the equation of the line parallel to the x-axis? It has the form of y equals b, a constant, where b here is either y of a or y of b, which is the same, and thus the equation of AB is y equals 2. So again, since the ordinates of A and B are the same, then I deduce that the line AB holding them is definitely parallel to the x-axis. And any line parallel to the x-axis have the form of y equals a constant. That constant is indeed equal to the same ordinate of the points it passes through. And another example, also concerning special cases, given the 2 points a minus 1, 4 and b minus 1, 2, we notice again something special here. What's the special thing among a and b? They have the same abscissa. So xa is equal to xb is equal to minus 1. That means that xa and xb are the same. That means that a and b belong to a line parallel to the y-axis. So point A is minus 1 somewhere down, minus 1, 4 upwards, and B is minus 1, 2. So A is somewhere here. Let's see. Here is 3, then let's see, here is 4, then A is here somewhere. Here is point A, and B is minus 1, 2, then here is B. So notice that A and B are both on the same line that is parallel to the y-axis. And the general form of the equation of the line that's parallel to the y-axis is x equals a constant. Where do we get this constant from? From this same value they have. So the equation of the line AB is then x equals minus 1 as the same as the abscissa of both A and B. And these are examples in order to let you know how to write the equations of special lines. Because if you are going here to find the slope of this line, you are going to write ya minus yb, which is 4 minus 2, over xa minus xb, which is minus 1, and minus minus will give plus 1, which is 0. And that's impossible for fractions to have a 0 denominator, so we may face troubles using the rule of the slope here. So we have to think smartly in order to discover that they both have the same abscissa, to discover that they are on a line parallel to the y-axis whose equation is x equals minus 1 as the same abscissa as the 2 points. And we can use the help of the sketch to make things easier. Thank you for watching. Hope you enjoyed lines in the coordinate system, and hope you are going to train more and more and solve more exercises to be so confident in this chapter.